So, group theory is the systematic study of symmetry and symmetry elements. And if we talk about the application of symmetry, group theory, it helps us to understand the various properties of molecules, such as its application of group theory, in which we study vibrational modes, IR and Raman activities, electronic transitions, molecular symbol, formation of character tables, and we can also get help from formation of the hybridization and formation of direct products. So before getting into the application, we need to know about some basic concepts, which are symmetry operations, symmetry elements, some symmetry elements such as axis of symmetry, plane of symmetry, center of symmetry, improper axis of symmetry, and identity. These are the main important 5 symmetry elements which are present. Axis of symmetry is represented by Cn, and plane of symmetry represented by sigma, and center of symmetry is represented by I, and improper axis of symmetry is represented by Sn, and identity is by E. In short, we can write these. After knowing this some basic concept, we can make point groups, which are the collection of these symmetry elements, and with the help of that we can give information about some reducible and irreducible representation of point groups. So these are some notes which I write. After that, we need to know about the major difference between what is symmetry operation and what is symmetry elements. So, corresponding to one symmetry element, we have many symmetry operations. So this sentence, its meaning is basic, is that we can distinguish between the identical and equivalent structure. If we take an example, let's take an example of H2O. And if we put a C2 axis, 180 degree rotation is happening, and this type of rotation is being seen here. Oxygen, if we put this hydrogen as 1 and this hydrogen as 2nd, then after 180 degree rotation, this hydrogen will come here and this hydrogen will come here. And if we put again 180 degree rotation, C22, then the identical structure of water is come with the same hydrogen present. So according to this, these two structure is called equivalent. Not identical means they are same but a little different, and these structure are called identical. So if we talk about how many symmetry operations are here, so there are 2 symmetry operations is present, C21 and C22. 2 operations are present. Let's understand this with another example. Let's take an example of BF3. If we draw the structure of BF3, we see a trigonal planar structure, and if we pass a C2 axis, a C3 axis from its middle, then we will get, if we consider this as F1, F2 and F3, and after C31, 120 degree rotation, then this boron will be in the center, and this fluorine turn here, this fluorine turn here and this fluorine turn here if you rotate in this direction. Then the structure that we get is an equivalent one. So these are equivalent structure, and we can do some more rotation from here. 120 degree rotation, C3 2, this boron, again come this F2 here, this F1 here, and this F3 here, and we can still do one more rotation for the C33, which is equal to identity. If this identity came with a formula, with a note, let's make it a note, according to which if C33 is equal to identity, not identity E, or if we put N here, then it is equal to E. Let's get back from that, and again this structure will be identical, as same as the one. So these are identical structures. These are also equivalent structure. And this is also an equivalent structure. So here two equivalent structure is present and one identical structure is present. So here the number of symmetry operations that are performed in this example is 3. 2 is C31, C32 and identity. So let's make a chart in which we put the symmetry elements and their symbols and their symmetry operation. Operations is the process in which we perform some actions just like in axis of symmetry. The symbol is Cn, in which we place principal axis and subsidiary axes, and the operation that we perform here is rotation. And the second symmetry element, that is plane of symmetry. Here we put different planes such as vertical plane, horizontal plane and dihedral plane. These three planes can be put in plane of symmetry, and here we see the operation that we perform is reflection. After performing this vertical plane, we see if the reflection of the element is seen or not. After that, center of symmetry. It is represented by I, and it is just like performing same from every side. Is going from one part to another part and then coming back from another part to same part in a structure. It's called center of symmetry. And after that, improper axis of rotation. Here two type of operation has been performed, and it is represented by Sn, in which an axis of rotation, an axis of symmetry which is perpendicular to a sigma, means a plane, it is represented by, which is equal to Sn. It can be just an example. C2 is perpendicular to sigma, which is represented by S2. And in last, identity. which is present in every molecule. It means 360-degree rotation. Here no change has been happening to the molecule in the symmetry operation.